Welcome back, everyone. We're diving into a truly epic mission today. We're talking about bringing pieces of Mars back to Earth.
Yeah, the Mars sample return mission. Ambitious doesn't even begin to describe it.
Huge undertaking. A joint effort between NASA and the European Space Agency. And it really could rewrite what we know about Mars, maybe even about life itself.
Absolutely. This is a multi-stage mission. We're talking multiple spacecraft, a whole relay race across millions of miles. It's a technological marvel and a scientific dream all rolled into one.
So let's break it down, starting with the heart of it, all the samples themselves. They're not just any random Martian rocks, are they?
Oh, definitely not. We're talking about samples from a very special place.
Jezero crater, right?
Jezero crater. It's believed to have been an ancient lake bed. So think about it, sedimentary rocks, potentially billions of years old.
Like time capsules holding secrets about Mars's past, maybe even signs of ancient life.
Exactly. That's the ultimate hope.
So our star player in this whole endeavor is the Perseverance rover, right? It's already on Mars, hard at work collecting these precious samples.
Perseverance is doing an amazing job. It's not just scooping up dirt, though. We're talking sophisticated drilling, extracting core samples.
Oh, yeah, I saw some images of that, those cylindrical tubes of rock.
Precisely.
You...
Martian cores sealed inside incredibly durable titanium tubes, each one about the size of a pencil.
Wow. Talk about high-tech Tupperware. But Mars is a pretty unforgiving environment. What if something goes wrong during sample collection?
Well, that's where the mission's redundancy comes in. They've thought of that.
Yeah, remember reading about the first sampling attempt?
Oh, right. The rock crumbled.
Perseverance ended up with a hole but no sample. A reminder that working on Mars is full of surprises.
Absolutely. So to avoid coming home empty-handed, Perseverance isn't just keeping all the samples it collects. It's been making deposits at a special location.
The Three Forks Sample Depot, right? I like to think of it as a Martian cellular deposit box.
Exactly. A backup stash, just in case. 10 backup samples are already there, waiting.
Smart move. So Perseverance is steadily building up this incredible collection. And these samples, are they all pretty much the same? Or is there variety?
Oh, they're incredibly diverse. As of October 2023, 27 samples.
27 already.
We've got igneous rocks, sedimentary rocks, regolith, that's the loose stuff on the surface, even samples of the Martian atmosphere.
Hold on, samples of the atmosphere.
Yeah. Perseverance has an instrument for capturing atmospheric gases, stores them in those same titanium tubes.
That's incredible. So we've got this amazing collection of Martian goodies safely tucked away, but getting them off Mars, back to Earth, that's where things get even trickier, wouldn't you say?
Oh, yeah. That's where the real adventure begins. Buckle up.
Okay, so picture this. We've got these incredibly valuable samples sitting there on Mars, just waiting to come home. What's the next step in this grand plan? How do we actually get them off the red planet?
That's where the next star player enters the scene. A spacecraft called the Sample Retrieval Lander, or SRL for short.
The SRL, catchy name.
Launching in 2028. This thing's going to be carrying some seriously sophisticated hardware.
I've heard it described as like a two-car garage packed with tech.
That's a pretty good analogy.
Yeah.
And the SRL has one very important job. Pick up those samples and get them into Martian orbit.
It sounds simple enough.
Oh, but the landing itself is going to be a nail-biter.
Oh, why's that?
Well, the SRL needs to land within 60 meters of Perseverance.
60 meters. That's what, like the length of a football field?
Pretty much. And remember, this is all happening remotely. Commands being sent from millions of miles away.
Talk about pressure. A
Yeah.
Martian parking job with no room for error.
You got it. And this is where our friends at the European Space Agency come in. They're playing a key role in this part of the mission.
Right, the ESA. What are they contributing?
They're responsible for one of the coolest pieces of tech on this whole mission. A 2.4-meter long robotic arm.
Whoa, a robotic arm. What's that for?
It's going to be attached to the SRL. Think of it like a super precise crane. It's going to carefully pick up those sample tubes.
From Perseverance.
Yep, either directly from Perseverance or from that sample depot we talked about. And then it's going to transfer them to the next piece of this puzzle, the Mars Ascent Vehicle.
Okay, the MAV. And this is what actually launches the samples off of Mars.
Exactly. The MAV is where things get really, really interesting. We're talking about the first rocket ever launched from another planet.
A rocket launching from Mars. Mind blown.
It's a two-stage, solid-fueled rocket. And they've had to overcome some pretty incredible engineering challenges to make this happen.
Yeah, I bet. Launching a rocket from Earth is complicated enough. What kind of unique challenges are we talking about here?
Well, for one thing, the extreme cold on Mars. It can get incredibly frigid, which can really mess with delicate machinery.
Yeah, I wouldn't want to be out there without a good spacesuit.
Another big challenge is weight. Every extra ounce on a spacecraft means more fuel needed to launch it, which translates to higher costs.
So, keeping things lightweight is crucial. Makes sense. What else?
Another tricky thing is that they won't know the exact mass distribution of the samples until they're actually loaded into the MAV. It's like building a rocket with a mystery box inside.
Ah, so that adds a whole other layer of complexity.
And then there's the fact that the second stage of the MAV is going to be spin stabilized.
Spin stabilize. Okay, you've lost me. What does that mean?
Well, instead of being actively guided, it's going to spin like a top as it ascends into Martian orbit.
So they're basically launching a spinning rocket.
It's a clever way to save weight, by not needing heavy guidance systems. But yeah, it adds a whole new level of challenge to the launch.
So no live telemetry during that second stage burn.
We're going to be flying blind, so to speak, at least for part of the journey. But don't worry, they've got a plan.
Oh, good. I was starting to get a little nervous. What's the plan?
The spin second stage of the MAV is going to have a radio beacon on board, constantly transmitting its location.
Like a cosmic breadcrumb trail.
Exactly. And those breadcrumbs lead to our precious cargo in Mars orbit.
So who's going to be following those breadcrumbs?
That's where the next hero of our story comes in. The Earth Return Orbiter, or ERO.
The ERO. Okay, what's its role?
This ESA spacecraft is going to be patiently waiting in orbit around Mars. Its job, rendezvous and capture.
So the ERO is going to play a kind of cosmic catch with the sample container.
You could say that, but it's not going to be easy.
I bet.
The ERO's got to find this tiny spinning container against the backdrop of space. It's a needle in a haystack situation.
How are they going to pull that off?
Well, the ERO's got some seriously impressive tech on board, state-of-the-art cameras, and LiDAR.
Radar.
Light detection and ranging. It uses lasers to measure distances.
Ah.
So that'll help them pinpoint the container's exact location. And actually capture it, the ERO has what's essentially a giant net.
A giant space net. Seriously.
Seriously. Designed to gently snag the sample container and secure it for the long trip back to Earth.
Wow, this mission is sounding more and more like something straight out of a sci-fi movie.
It's pretty wild, isn't it? But it's all very real. And it's happening.
So we've got the samples launched into Mars orbit, safely tucked away inside the ERO. What happens next? How do they get back to Earth? Okay, so last we left off, our precious sample container was snug as a bug in a rug aboard the Earth Return Orbiter, safe and sound, but still millions of miles from home.
Right, but that journey back, that's where the ERO really shines.
Yeah.
This spacecraft, it's a marvel of efficiency.
It's going to be using ion propulsion to get back, right?
Exactly. Ion propulsion, it's incredibly efficient, sips fuel like a hummingbird.
But I seem to remember it's not exactly known for its speed.
Yeah, it's a bit of a slow boat to China, cosmically speaking. But that's where those massive solar panels come in.
The ones with, what was it, like a 38-meter wingspan?
Bigger than a Boeing 737, they'll be soaking up sunlight, powering those ion engines for the long haul.
So the ERO is going to be gradually spiraling out of Mars orbit and cruising back to Earth, solar-powered and carrying its precious cargo. But what happens when it finally gets here? Does it land like a regular spacecraft?
Ah, that's where things get a little more dramatic. The ERO itself, it's not designed for landing on Earth.
Okay, so how do we get our samples back?
Well, think of it like a Russian nesting doll. Inside the ERO is a smaller capsule, the Earth Entry Vehicle, the EEV. And that's what's coming home.
Ah, so the EEV is the one that actually makes the fiery descent through Earth's atmosphere.
You got it. Designed to handle those intense forces, heat, pressure, you name it, protecting those Martian samples all the way down.
And I remember hearing something about this landing. It's not exactly a typical touchdown, is it?
Nope. This one's going to be a little more, shall we say, unorthodox. No parachute.
Wait, no parachute. Seriously?
No parachute. The EEV is designed to make a controlled, hard landing.
A controlled crash landing. Where exactly?
The target is a remote area of the Utah desert.
So they're basically aiming for a specific spot in the desert and just letting it go.
Well, it's not quite that simple. The EEV will have a navigation system to guide it, and it's designed with special shock-absorbing materials to cushion the blow.
So more like a high-tech bounce than a crash.
That's a good way to put it. Think of it as a very carefully orchestrated thud.
And when is this grand finale set to happen?
Current plan is for the EEV to touch down sometime in 2033.
Still a few years off, but man, what a moment that's going to be. These samples, collected by Perseverance on another planet, finally back in the hands of scientists here on Earth. It's just mind-boggling.
It really is a testament to human ingenuity, pushing the boundaries of what's possible.
So what are the scientists going to do with these samples once they get them? What are they hoping to find?
The possibilities are endless. I mean, we're talking about analyzing these samples with instruments and techniques that would never fit on a spacecraft.
So they'll be looking for signs of ancient life,
Yeah, it's
obviously.
definitely high on the priority list.
Yeah.
But it goes beyond that. We can study the Martian climate, the geology, the composition of the atmosphere in unprecedented detail.
Who knows what secrets these samples might hold? I mean, they could tell us so much about the history of Mars, maybe even about the early solar system, the origins of life itself. It's incredible to think about.
And remember, this mission, it's not just about Mars. What we learn could have implications for our understanding of Earth, of how planets form, of the potential for life elsewhere in the universe.
It's a reminder that we're part of something much bigger than ourselves. This mission, it's a testament to the power of human curiosity, our drive to explore the unknown, to push the boundaries of knowledge.
Couldn't have said it better myself. And it's worth remembering, this whole endeavor, it's faced some challenges, especially with budget concerns lately.
Right, there's been some talk of needing to streamline the mission to keep it affordable.
Exactly. But even if things have to be adjusted, the core of the mission remains the same: to bring pieces of Mars back to Earth and unlock the secrets they hold. It's a mission worth watching, worth following, worth getting excited about.
Absolutely. This has been an amazing deep dive into the Mars sample return mission, a story of ambition, innovation, and the relentless pursuit of knowledge. A reminder that even in the face of immense challenges, human ingenuity and the thirst for discovery can prevail. Thanks for joining us on this epic journey.